Jo Boram, a lead teacher working at Pungam High School, in Gwangju. This time. 1. A simple Arduino Simulator site introduction. 2. Building the piano circuit. 3. Arduino used in real class, will be lectured to you. Access the Tinkercad site. Register or log into the site. When you click on the dashboard, this screen appears. If you click Circuits on this screen, you can build circuits with the simulator. On the first try, there will be a Try Circuits button. Click this. If this button does not exist, click Create New Circuit. Finally, the circuit simulator is available. Select the device you want to use on the right. I mainly use Arduino in class. Arduino is very convenient because it does not require soldering and can control various input-output devices. It has a very appropriate level of difficulty for use, from middle school to high school students. Don't try too many things in the first class. Give students a chance to familiarize themselves with the simulator. We will practice simply turning on the LED. This is a very simple circuit configuration. Find the GND pin of the Arduino. This is an abbreviation for ground, and acts as a minus pole that accepts electricity. Connect the minus pole to the breadboard. At this time, set the color of the wire to a dark color. We usually use a light wire for the plus pole, and a dark wire for the minus pole. A single row of breadboard connected to GND, all have GND polarity. Connect the minus pole of the LED and GND of the breadboard with a wire. The bent side of LED's leg is positive, and the straight side is negative. The plus part of the LED needs a resistor connection. LED usually uses a voltage of 1.5 volt to 3 volt because a voltage of 5 volts flows through Arduino. When you click on a resistor, a field for setting the name of the resistor, the unit of the resistor, and the number will appear. Set to 200 ohms. Connect a wire to the resistor and the Arduino 5 volts pin. At this time, use red or light-colored wires. After completing the circuit configuration, click the Start Simulation button. Run and you should see the LED light up. If only the LED circuit was composed, this would be a physics class. We will write code to control the LED. The configuration of the circuit does not change significantly. Click once on the wire connected to 5 volt. And drag the part connected to 5 volts with the mouse to move it to 3. And we write the code. First, use blocks. Blocks is similar to Scratch blocks. Since I am teaching high school students, I will use text. Arduino code is largely divided into setup and loop. Void setup sets pin mode. In the void loop, we control the LED. The code is not difficult either. Create an integer variable called LED with code. And put 3 into that variable. What this means is that we connected LED to pin 3 when we built the circuit. As mentioned earlier, set pin mode in setup. Note that only M is capitalized. Pin mode has the following format. This is pin mode. Since LED is number 3, use LED instead of 3. Input. Output mode setting commands are input and output. Set it to output because the LED will turn it on and off. In the loop part, code the action to turn on/off the LED. This code is a command to send current to the LED with digital pin inserted. If you put low, no current flows. In loop, there is a code for the LED to turn on for 1 second and turn off for 1 second. If you simulate this, you can check that LED turns on and off repeatedly. This simply relieves students' tension with the LED and moves on to the buzzer practice. The buzzer will use a piezo, erase the LED and resistor, and connect the buzzer. You can change the position of the plus and minus using the left and right symmetry buttons. The buzzer will also connect plus to 3. And rewrite the code. The code to control the buzzer is as follows. Define the frequency by the name of the scale. For example, use the code that C4 is defined as 262. If you cannot memorize everything, go to the Arduino.cc and click the tone code in documentation reference. When you click down tone melody, it will give you the defined codes from B0 to D9. Using this, look at simple nursery rhymes and write code to play the song on piezo speakers. The code I wrote is the song Happy Birthday. Next is a laser gun making class that I use in real class. The laser gun used a commercially available toy model gun. Real Arduino Nano board, breadboard, tilt sensor, battery holder, switch, laser part, and LED were used. Here's the circuit. The number is the Arduino number to be connected. Here's the code. It is divided into 3 parts: variable declaration, setup, and loop. Students were provided with parts introductions, schematics, and code to be free to create. It took about 3 hours to compose the circuit. I modified the code over an hour to complete it. This is a picture of the students making them. The completed laser gun will be used for the second semester physical education evaluation. When the finished gun is shaken, the value of the tilt sensor changes to load. Loaded status is indicated by lighting the LED. The moment the trigger is pulled and released, the switch is disconnected and a laser is fired. After that, the LED and tilt sensor are reset. Power on the battery holder. You can keep reloading and firing lasers until turned off. In addition to this, you can design a computing system that students want to make by themselves or create in class project classes. In Korea, for 1 semester, I conducted a project class using Arduino to make a window that closes automatically when it rains, a robot arm controlled by a mobile phone application, etc. Arduino Simulator is provided by Tinkercad site. Tinkercad site provides it for free. For cloud storage, we must log in and use the simulator. Arduino can only be purchased in Korea. You can purchase not only Arduino wires and parts necessary for circuit configuration using the Amazon site, etc. Next class is the latest EduTech trends and their use in classes.